A driver of a car travels at 52 km per hour, applies the brake and accelerates uniformly in the opposite direction. So we have a person traveling at 52 kilometers per hour. So obviously post brake, the vehicle will deaccelerate. The car stops in 5 seconds. Okay, it's a continuation. So we have another car going at 3 km per hour. So one main thing is these are in kilometer per hour and this is in second. Again, units are the one which we have to be careful with. Everyone makes a mistake in units because of units and writing units. Okay, so be careful with or underline those to be frank. Right? Okay. And stops. The keyword here is stop. That is, it's coming to rest. Applies his brake slowly and stops in 10 seconds. On the same graph, plot the speed versus time graph for the two cars. Which of the two cars traveled further away after the brakes were applied? Okay, so first thing first, let's visually simplify this. So we have a car, both are of same model, so one single car indicates both the scenarios. It's traveling, say, towards the right. Since we are applying brake, the force of friction would be in the opposite direction. Remember, always acceleration. I'm indicating acceleration with two arrows. Whenever you have things in opposite direction, something like this, so this is your motion. Motion and force are in opposite direction, acceleration will be negative. Okay, if I consider right to be positive, that is motion direction is positive, this will be negative. This you'll understand in time, so just keep this in mind. So the vehicle in both the cases is coming to rest. What does it mean? Yes, the final velocity is 0 meter per second. Right, so let's move on. We have case 1. Initially the vehicle was moving at 52 km per hour. We have to convert it to meter per second, and so we have 1 kilometer per hour being converted to 100 into 60 into 60 meter per second. So we have 1 2 1 2. This is 10 by 6 into 6 meter per second. So basically 52 would be equal to 52, sorry, u would be equal to 52 into 10 by 6 into 6 meter per second. And so we have 226 are 2 3s are 2 13s are 2 3s are, and we have 130 by 9. That would be 14, right? No, wait. 1s are 9, 40, 36, yes. 14.44 meter per second approximately. That would be your first velocity, that is the first cars. And similarly, oh yeah, we need to talk about time also. Time is 5 seconds. And now we are looking at u2. So this is 3 km per hour. That would be 3 into 10 by 16, 6 into 6 meter per second. So this would be 2 and 5, and this would be 0.68 are 48, then 2, 3, 3, 3. So that would be so many meter per second approximately. And the time is 10 seconds. The person takes 10 seconds to get it to rest. Next thing is the plot. On the same graph sheet, speed versus time. So we are looking at speed versus time graph. So this is your initial scenario. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what is this? This is a speed versus time graph. So this is the time. So the maximum time is 10 seconds. And the minimum is 5. So we can use 0, 1, 2, 3, 4. Here along the y-axis we have 14, that is the maximum. Least is almost 0, so almost 1 actually. We have to go with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and somewhere along over there is 15. So 14.4 is somewhere over there. So if you want to learn graphs better, you do have it in your syllabus. So please watch the graph topic, linear, no, I forgot what is the name of the topic. So you have that. You watch it over there, you'll understand all of this in detail, because every question I've discussed in detail and I've emphasized on the same things, deciding on the scale and all of that. Okay, so the vehicle at the initial point, initial is 0, is it not? Initial of the, so this entire journey, the initial point is 0, is it not? It had a velocity of, so this is, remember, meter per second, and this is time in seconds. So this is a velocity time graph. So initial is your 0th second. So 0th second, the velocity is 14.44. And within matter of 5 seconds, it comes to 0. And we have the graph to be this. While in the other case, we have 8.33 and comes to 0 in 10 seconds. I think I remember the values right. So just let me have a look. 8.33 and the other one is 14.44. Okay. So this is, let me complete the graph. Title is velocity time graph. Scale is along the x-axis. For every centimeter, we're looking at 1 second. Y-axis, for every centimeter, we're looking at 1 meter per second. So title, scale, these things, and this is car 1, and that's car 2. This is a complete graph. Okay, and now we have the calculation of the distance traveled. So we have distance 1 will be equal to area of triangle OAB. So that would be OA and that is B. So this is equal to half into base is OA into OB. So this would be half into base is 5 into height is 14.44. So you can do this 2 ones are 7.22, then multiply 35 and 136.1 meters approximately. So that is the distance traveled by the first person in the matter of 5 seconds. Now distance 2 is area of the other triangle OP and Q. Triangle OPQ, which is half into base is OQ and height is OP. So half into base is 10 into height is 0.83. 2 ones are 0.415. So this is 4.15 meters approximately. Okay, the last bit of the question is, you can see over here, which of the two cars traveled further after the brakes were applied? So clearly the car 1. The car 1 traveled farthest, right? This is your complete answer. So we can simulate this, same thing can be simulated. All we need is acceleration. So this is an extra bit, you need not do it in your exam. So acceleration you can calculate with v minus u by t. V is 0 minus 14.4 divided by t, that is 5 seconds for the first vehicle. So this would be 14.4 divided by 5 is 2.9 approximately. And the second one is 0.8 divided by 0.083 meter per second square. Okay, then we have to go to the plot, the program. We have to change the initial velocity, acceleration and all of that. So initial velocity is 14.44 and your acceleration happens to be 2.9, and that's it. Everything else is okay. You need not type negative. The program handles the braking part. So you just have to type in brake. Okay, so here, I don't know if you're able to see, there are 5 to 6 of them because it took 5 seconds for the vehicle to stop, right? So that's what you will get. See that within 5 seconds, the velocity became 0. And the distance would be over here. Whatever this point is, that is the distance traveled by the thing. If not, you find this area, right? Is it not? So this is basically your required graph, right? So it starts from around 14 point odd till 0, from 0 to 5 seconds. So this is your linear graph. That's what we drew. And to find the distance, you just scroll over. So here you have your answer. Okay, you can check out the coordinates over here. You just go to that point, exact point. So around 5 seconds and 36. We kind of got the same thing, right? 36 is over here. And the last second one is, and see the graph. Please see the graph. It's the same thing. Of course, here it looks different, but if you scale it down from 0 to 10, or scale it up, down, something, it will look a bit closer and longer. Okay, so this is how you can simulate it. So in this other cases, the vehicle has a velocity of 0.83. It has a velocity of 0.83 and the acceleration is 0.83. Okay, and now let's simulate this. So you can see over here I'm breaking it. I'm typing the program to break it 3 times 4th, 5th, 6th, 7th, 8th, 9th, 10th. Okay, one extra bit came in, but anyways, that is handled by the graph. So you can see over here it's almost didn't move. That's the whole idea, right? It had a very small velocity, initial velocity, and it came to 0 within 10 seconds. That's what the question had told. And to find the value, just check where that graph intersects. So this would be over here, and you can see over here almost 10 seconds, and the answer is 4.15. So we have the answer to be 4.15 meters. Is it not? So that is your answer. See, you can simulate it also. And you can see the velocity time graph. So it's starting from around 8.3ish, and obviously we typed in so, and it's ending up at in a matter of 10 seconds. We didn't type, but yes, you can see that it's the same. So you can learn a lot of things by doing all of this. Try doing it. It takes around 5 minutes. Once you get used to it, it takes on 2 seconds. I have to explain it, so all of this. Simulating will take less time, but yes, try to analyze it, try to learn, look at each graph, look at acceleration. So do all of that, it will be helpful. And look at this nature of graph, it looks like a wave, right? Anyways, so this is your answer.